Hello. Hello. Firstly, a huge thank you to everyone who's come along. I was expecting about 10 people, so this is nice. I'm here to talk about how we managed to enable AI in an NHS organisation, particularly an acute hospital, with Botley Dash. So, firstly, just to sort of introduce myself. So, I currently have 3 roles. I'm the head of data science, artificial intelligence, and operational research for Somerset NHS Foundation Trust, where I manage a team of data scientists, service evaluation analysts, and researchers trying to deliver predictive and prescriptive analytics for our organisation. I also am the interim technical director for the Great Western Secure Data Environment, which is a big subnational initiative to try and amalgamate the huge amount of healthcare providers in our region. So we currently have 186, and we're trying to centralise all those into a single place. And then when I have some spare time, I'm an associate research fellow looking into causal impact analysis, particularly a simulated causal impact analysis, so that we can model changes in complex healthcare systems. But in my main role, I work for Somerset NHS Foundation Trust, so we employ about 12,500 staff across 2 large acute hospitals, the Yeovil District and Musgrave Park. Responsible for the care of about 500,000 people. Got 13 community hospitals. We provide mental health and social care services, and we have a quarter of all the GP practices in Somerset. So we're quite a substantial organisation now. We've merged from 3 different ones. So before I get into sort of our experiences trying to embed AI, I just want to try and explain the challenges we had before we started that journey. So you may be aware there's a big national paper called the Data Saves Lives Strategy. It's also got the Goldacre Review. It's the same paper. And it's 170 pages outlining all the things that the NHS has to try and adopt over the next 5 to 10 years, all the different methodologies and concepts that we need to do. So when we had to start looking for an option to solve all our issues of AI, one of the key ones we had to try and factor in is interoperability. And we're not just talking about interoperability within our own organisation, it's also external organisations. So as a hospital, I need to be able to send the visualizations and the data and the outputs of the models that I make to other hospitals who may not have my software or any compatible software with me. So some organisations might be using, for example, Tableau, some might be using ClickView, some might be using Power BI. They may all be using different versions of SQL, and they may all be using different versions of Python, R. So trying to find something that would work for everybody was one of our first challenges, and it's something that the policy really emphasises, is that interoperability component. We also have to adopt the principles of reproducible analytical pipelines. So all the things that we create need to be able to ingest, process, model, and report in an automated way. So any solution that we would have to find would have to be able to do all 4 of those things in one package. And finally, we are heavily pushed towards anybody who has open source principles. So that can be things like contributing to Python packages or R packages, doing research papers that are available to the public, best practice guidances, papers and talks. But any organisation who has open source principles and has made the effort to contribute to the community without that paywall takes preference over those other organisations. Alongside that, and sort of at the same time, when we were going out to procurement, the only people who seemed to be interested in working with us were people who were trying to sell this concept to us of low-code, drag-and-drop, AutoML. And every single company would come up to us and say, our product's completely unique, and they would all be the same, doing exactly the same thing. They would only do a part of that reproducible analytical pipeline, so we just couldn't use those. And it's also a little bit cheeky, because we know we can do AutoML for free. There's things like PyCarrot, we can do that. So to charge for that isn't really what we wanted to do. There's also getting organisations who are trying to sell the product to us to understand the sheer volume of an NHS acute trust. So we have thousands of use cases. There's no single one-size-fits-all approach when it comes to trying to create models. So we have over 100 treatment specialties carried out over 100 different sites, with them coming in as outpatients, inpatients, mental health patients, diagnostic theatres, maternity, social care. There are so many different ways that we need to chop and change the data. So we needed something that was going to be completely flexible with the way we worked as an organisation, not something which was being advertised as a single solution. And in our world, the best people to do that is models that are built bespoke by NHS data scientists. So we spend every day working with the people to try and make sure that they understand the reporting and the outputs that we produce. And every organisation is slightly different. So they have a different ratio of staff to patients. They'll have different treatments that they can deliver. They'll have different policies about how they can do things. So you really can't do a one-size-fits-all approach to it. Everything has to be built bespoke. And our data scientists are the ones who are really driving that forwards. And finally, one of the biggest challenges we had when we were looking for is we need to be able to get all those complex data science models and visualizations actually to the users. And that user base is hugely diverse. It's 12,500 staff with all different varying levels of data literacy. And there were quite a few offerings we had where we were looking at it and we were going, okay, well, yes, you can do machine learning and you can give me a rock graph, fantastic, but I can't give that to any department, they won't understand it. And we actually need to be able to build completely new visualizations based off that data. That accuracy information is more for data scientists, it's not for our users. So we spent about 6 months looking around the market, AutoML constantly coming up and saying, oh great, it's a drag and drop solution. And we finally stumbled upon Plotly. I say stumbled on, we've been using Plotly open source for about 4 or 5 years in the graphing libraries. So we knew a lot about what Plotly's sort of business understanding and their transparencies. They've had huge contributions to the open source market. They also had the opportunity to, they gave us the opportunity to natively run whatever we wanted. So in Plotly Dash, it's an application that you can build. You can make it bespoke to exactly what you need. And we've managed to build some models, which I'll come on to in a moment, almost entirely open source, because we can utilize the open source libraries that are available in Python and just combine it with the infrastructure that Plotly provides us. And there's a huge amount of interoperability and being able to share the code. Because of that open source principles, we can share our code with completely different organizations and they can still run that as long as they have Python. So I'll just run through a few examples of how we've managed to actually apply that in our world. So one of the first projects we did was an AI-enhanced emergency care dashboard. So we were stuck in the rut as an organisation where we were just doing these static dashboards that provided very little information, and people weren't really using them. So what we decided to do was go down to the emergency department, and we built all of their reporting from scratch. So we made all their reporting as live as it could possibly be. So it's about 20 seconds between the system storing it and getting back to our reports. And then we started to ask them questions about how we could incorporate AI into those models. So one of the ways we did that is when somebody comes into our organisation, a proportion of those will get admitted to our hospital. Unfortunately, as you've probably seen in the news, the NHS is under huge pressure, and there's huge backlogs and people waiting over 4 hours and 12 hours, and that's not what we want as an organisation. So what we tried to do using AI is typically when you come to an ED department, about 3 hours after you get there, if you need to be admitted, that's when the decision to admit will take place. And they'll contact our patient flow team, and the patient flow team will work very, very hard to find you a bed in the hospital. With the AI that we managed to build into the app, when they get triaged 15 minutes in, we built a classification model that would predict whether they were going to be admitted or discharged. So we took that window of 3 to 3.5 hours all the way down to 15 minutes, providing our patient flow team with hours to look for beds rather than minutes. And it's led to a decrease in our 4-hour breaches and our 12-hour breaches. We also managed to put time series forecasts on our arrivals coming in over the next 48 hours, the admissions happening over the next 48 hours, our occupancy as a department over those 48 hours. And all that information has now given our emergency department huge amounts of insight into how they can start to try and prevent adverse incidents happening in the future, trying to get those patients flowing through the department much, much quicker. And everything that we built here was using open source libraries. We also built a geospatial application. So a big thing that we're asked every year is, are our services being conducted in the right places in our county? So a member of my team built this amazing app which uses clustering algorithms to work out where we should place services in Somerset based on patient demand and need. And there's other bits built in terms of like understanding our population, social deprivation, understanding travel distances between clinic services so that we can try and reduce our carbon footprint as an organisation by providing services closer to people's homes. We've also created, so a huge part of what I do is I work for the Service Evaluation Directorate. And whenever a change happens in the organisation, it typically comes to our department and we basically measure whether that change was effective. So we created a causal impact analysis application where anybody could just drop their data into it. It would perform a causal impact analysis. It could also perform a statistical process chart, depending on what type of change they're trying to measure. And there's also hypothesis testing in there as well. But instead of us having to do all those very, very repetitive causal impact analysis studies, we can give the actual staff the ability to do it themselves. And instead of spending the time doing it, we actually can spend time training them in understanding change theory and improving their data literacy with data and data science. And again, all of this was built using open source libraries. There was no additional cost to incorporate any of this in. And just over the past year, so as I said, we built a statistical process chart application completely in-house. We didn't have to go out for costly third-party providers. We've utilised the SK Time library, and we've built a hospital healthcare-based time series forecasting application, which again was completely open source. There was no additional cost to build that tool. I mentioned also ML at the beginning. We built our own, based in the healthcare system, based on PyCarrot, which is tailored towards the professionals that would actually use it, those healthcare people, those doctors, clinicians, nurses. And we can spend a lot more time with them actually explaining how the machine learning works. And finally, we've been building a simulated demand and capacity modeling using SymPy, again, another open source library, utilizing what's available to us via Python and R, and just having this visualization tool with Plotly Dash to be able to actually get it to the end users. So that's sort of the gist of my presentation, and I've left some time on purpose for some questions, if there are any in the audience. Yes?
Thank you, really interesting. Curious, how big a team do you have?
I can't hear you, so I will.
How big a team do you have building the applications, and have you had any challenges with the skill sets that are needed to work?
Scuttle back now. So the data science team is currently 4 data scientists and a service evaluation analyst. So it's a relatively small team considering the size of our organisation. We're quite a new team. It has been difficult to embed AI in the NHS. So that's been one of the biggest barriers that we've sort of faced. In terms of skills, I think there's sort of an industry progression at the moment. Thank you. There's a change in our industry where people are trying to adopt things like R. So obviously there's R Shiny in that world. But we've always been a Python organisation. So the actual skill gap wasn't that big for us. So we went from developing Python standalone sort of things in Jupyter notebooks, and we were trying to get those Jupyter notebooks away from just being on our computers. So the skill sets in the team are all there, and I think the NHS as an industry is starting to move towards using things like Python and R. So I would say it's very, very user-friendly as an app building. It's not huge amounts of JavaScript and then things like that. It's purely in Python, which if you're comfortable with Python or R, yeah, the skill gap's very low. I think you had your hand up first.
Can you hear me?
Okay.
Perfect. You said you were 4 data scientists. How do you prioritize the workload? You must have so much, a huge backlog. And how do you determine the value of the bits of the work that you've done as well?
Yeah, our backlog is pretty extensive at the moment. What we're trying to do as a mindset as a team is not sort of just answer the question, but if we're doing something like a time series application, we would rather build it in such a way that in the future they could do it themselves. So we'd rather spend more time on the training element of it and going, okay, we built this tool for you. We tried to make it as adaptable as possible to your area, but you can spend that time actually adapting it. You know your area better than the data scientists can learn it in a week. So that's our sort of main push, is to try and get people to own their own data science models, and we just provide the learning and the support around those things. What was the other half of your question? Oh, sorry, I can't hear you.
The value element as well. So how do you determine that? Was it worth it once you've done it, basically?
Yeah, that's it. So I think we've been quite fortunate at the moment that because it's such a new thing for our organisation, everything's just seemed like, oh, this is absolutely amazing, and so valuable. But I think what we're trying to do is, alongside that training element, is also understand that we only build things that benefit patients or our staff welfare or has an operational efficiency saving for our organisation. So those 3 things are our value metrics. If we can make staff's day a bit better, if we can make the patient experience better, get them through a hospital quicker, improve that efficiency as an organisation so we can see more patients, that's our measuring tactics. We try to stay away from any of those technical things because we're a healthcare organisation. We don't want to measure people based on those numbers. I think there was somebody over here. Oh.
Thank you. Could you comment a little bit or talk about how you chose what data to use? Because I could imagine in the health service there's a lot of quite sensitive data.
Yeah.
And you talked about how you're modelling what patients to put in beds. And I can imagine it'd be very unpopular if you use specific characteristics about the patient. If you could talk about that a little bit, it'd be great. Thank you.
Yeah, absolutely. So just to clarify with the model, so we're not choosing the bed based on the model. What we're saying is that somebody who's come in with these characteristics has a high chance of being admitted to our trust, and therefore we should start looking for a bed earlier in the journey. So the actual what bed they're going to end up with, that's decided by the patient flow team. This is just a decision support tool to try and help them make that decision earlier in the process. I waffled on then. Repeat what your actual question was. Oh, the mic disappeared again. Oh, to the left.
So I just have a question. Say like if I am the implementation lead and you're reporting to me, all right?
Mm-hmm.
So I'm going to ask you like, how are you going to convince me for the change? Why? Because let's say I'm already using a simple line chart in Excel, or I'm using a simple Python library with a matplotlib or SNS. I can just get the line chart. Why do you want to use time series forecasting? And how can you convince me to embrace change?
In our world, if somebody was using Python, one of our directors, we would be ecstatic. But I completely understand what you're trying to say. So the big thing is trying to make it in an applied way. So rather than just giving them line charts, which are almost meaningless, it's actually giving them stuff which they can visually see is benefiting them. So when we're doing things like time series forecasting, we can use cross-validation and actually prove the accuracy. And that's a really, really long, slow process of convincing them and going, look, we have been accurate in the past, and we can prove that. The same with classification and clustering. The big barrier tends to be convincing them on accuracy.
Yeah. So I just have one follow-up very quick. So the question is like, as you said, you're going to say like, this is how you're going to showcase there is a percentage change in accuracy and it's going to benefit the hospital in terms of running costs. But seems all right. But how did you manage in this case? Why? Because I know you have to report it to the directors, or you need to showcase them. You cannot just tell them directly that okay, this is the accuracy. I know they don't believe in numbers. So how? So that is the core essence I want to get out of it.
So the big benefit of using an open source piece of software is we built it and basically showed them how good it was without them having to commit any money. And then we came back and they were like, we want more of this. And we were like, well, I could do a bit more for you, but it's going to be really, really difficult. But it'd be easier if I did this. And we got the enterprise version. And we did that a couple of times with the ED app was originally completely just built on the open source engine. And we did it with the forecasting app. And over time, they started to realize, actually, we can't do without this stuff. But it's not just like an internal thing. There's the whole national policy is changing. So they know they need to embed data science. They can see it in other organisations. It's not just us going, look how amazing this thing is. It's we need to keep up with the industry. You can see what the industry is doing, things like ChatGPT and things like that. Or we need to keep up with that as well. I think I just remembered your question about where do you get the data. The data.
Is there much collaboration between different NHS trusts in terms of data science and artificial intelligence? And if so, sort of what channel do the collaboration take place?
So you'll probably find that data collaboration between organisations in NHS at the moment is very, very poor, especially when it comes to artificial intelligence. The barriers in the way in terms of data sharing agreements and the way that we can use data, and also just the trust in doing these things. There's been things like the Royal Free Hospital and the DeepMind scandals and Palantir and things like that. We have to be really, really careful as an organisation that that's actually done a lot of damage to the NHS being able to implement those things. So working between organisations is exactly what my role as the technical director of the Great Western Secure Data Environment is trying to do in making a safe haven for all those organisations to work collaboratively together, where all the patient data has been pseudo-anonymised, so you can do that. But as you can imagine, it's a lot of organisations who've never worked that way before, so it's going to be quite a long process. I think it's about 2 to 5 years it's going to take.
Sorry, did you find it hard to actually access the data and get it out of the systems and then clean it, or did you find that they had enough there for you?
I think in the NHS, we have some data sets which have been heavily standardised and they're quite easy to work with. But we're very, very used to working with very, very unclean data and having to make a lot of corrections to it. The benefit we had with taking sort of that programming-led route with something like Plotly Dash is that we could put all that in code and we could try to simplify that process. Like all the connections to our data sets are going directly through a warehouse, which is where all our analysts would report. So they're a separate team, the analyst team. We're all reporting on the same data. But we're just utilising the fact that we're a programming-based application, taking it from the same source, doing our own cleaning on it, and all of that's built into the actual application. So whenever we need to make changes, we can just go into our application and adjust it.
Hi, I just have a question around data literacy. So in our trust, we find it quite difficult to relay information usually. So I've just found, how did you find it delivering that training on the SPCs and using that visual?
Painful. I think for SPC, we were fortunate that was done before my time. But we were trying to teach things like causal impact analysis, which it's quite an advancement on statistical process charts, and again, to understand how probabilistic models work and saying, okay, well, we can't say for certain your change is effective, but we can say we're about 80% sure, and this is the reason why. But what we're doing as an organisation to try and help with that is we're releasing mandatory training, which all our staff have to do. So it's a half-an-hour course on basic statistics and graph reading. So all of our organisation will do that as part of our mandatory learning package. And then we're offering a dedicated course to senior, what we're calling decision makers. So anybody who's making a decision in an organisation needs to understand change theory and why they should be confident in change, and they have to use data-driven decision making. And then finally, there's a course where it's very, very focused on data science. So anybody in the organisation who wants to train from an analyst to a data scientist, we're sort of developing a week-long course where they'll learn the concepts, but it'll be applied in a healthcare setting rather than some of the online courses where it's very much a financial setting.
Hi, my question is regarding patient data. Do you do any predictive analytics on patient data? And if so, how do you handle the security or the privacy regarding that? Also, next question is, like, patient data can also be very easily turned into big data. And do you think that Plotly would still be able to handle those kind of algorithms on the dashboard? Because with big data, Plotly, would it be able to survive that kind of thing?
So for the first question, when it comes to working on patient data and these machine learning models, there are very, very few cases when you're doing data science that you should be putting patient data through. So when I'm doing a time series forecasting, there is no reason for me to put patient data through. When I'm doing causal impact studies, there's no need for patient data in it. I think the only time when you start to get into the risk is when you're starting to look at things like classification. And in a classification model, if you're putting patient data into that, like names or things like that, you're very, very unlikely to be improving the accuracy of that model, so you shouldn't be putting it in. So I think that whole concept of patient data and the whole AI space being really risky is just that misunderstanding that actually you don't need patient data to make an accurate forecast. Demographic data, absolutely. But things like postcode, you just take the distance, you wouldn't take postcode. Or male and female, absolutely fine. Age groups, absolutely fine. But you wouldn't say Joe Blogs with this medical record number, put that into a classification model, and just make it less accurate. For the second one of big data, so the ED department is our most critical department in the entire trust. The data that's going through that is huge. It's constantly updating, and we've had no issues. The benefit of Plotly is if our app gets too big, we just give it more resources. And we are not at a stage yet where we've hit that limit. We've got 8 deployed apps and about 20-ish sort of development environments. We're nowhere near the limit at the moment. But it comes down to developers that we should be developing in such a way that your apps are quick and they don't become super intensive. And 2 of the people in my team are software engineers by background, so we've got that experience in that. I think I've got time for one more question.
Thank you. I just want to check with you because I have not seen any customer reviews classification like it happens on Amazon customer reviews or IMDb movies. So there has been so much of patients' feedback online. Is there some kind of project you are working on where you can use that data to check what kind of sentiments are there for particular GP or hospital?
So GP data at the moment in the NHS is one of the separate organisations. So GP data rarely comes into an acute trust. But it's an evolving beast. We hope to develop that as part of the secure data environment work. At the moment, we can't do it because we can't access that data. Thank you very much.